Okay, hello everyone. Find the normal and tangential components of v, 3, negative 2, 2, with respect to the plane 2x plus y minus 3z equals 4. So we see that there's three variables here, and so the plane lives in three-dimensional space. And because the right-hand side is not 0, that means we've shifted the plane off the origin. So first, a picture. This is not going to be accurate, it's just a cartoon picture. So I have my three axes, and then I could draw the plane like going through the origin, but that would be wrong. So at least my picture can be sort of correct. So here's the plane like sort of away from the origin somewhere. And now v is also a vector in three-dimensional space. I could draw it, with its starting at the origin, going to some point 3, negative 2, 2. But for this picture, I'm just going to move the vector and start it somewhere on the plane. Doesn't really matter. Okay, so maybe here's v. Now, part of v will be normal to the plane, and part of v, you can imagine projecting the shadow if the sun was over here, shining light, parallel to the plane. The shadow would reach the plane at some point here, where this is a 90-degree angle. And so this is the triangle that we're going to use. So why don't I give these colors? This will be the purple vector. It'll be tangential. It's in the plane, so we call it the tangential component of v with respect to the plane. And let's take this one to be green. And again, now I'm projecting onto this normal line, the line that's normal to the plane, meaning that it has a 90-degree angle with respect to the plane. Okay, so first, we have a pink vector that's some length. I don't know how long it is, but it comes from the coefficients for the equation of the plane. This is the normal vector defining the plane. It's sort of the tilt of the plane, and it's 2, 1, minus 3. So I'm going to call it n, and I'll call it 2, 1, minus 3, n for normal. So we want the green and the purple. That's the answer. And now we look at a formula. So what's the green vector? Let's call that, I don't know, we'll call it w. So w is v dot n over n dot n times n. So remember, this is sort of the length of n squared. One part goes here, one part goes here. And if you don't know what I'm talking about, then look back at previous videos. And this is the formula for projecting the vector v onto the direction of the vector n. And it'll give the vector w, which has exactly the right length, so that we get a 90-degree angle. Great. Then what's the purple vector? Well, let's call the purple vector, I don't know, u, v, w, in order in the alphabet. And what's u? Well, u is going to be v minus w. v minus w. I could just write w, or I could rewrite this right there. So I could write that, or honestly, it's probably simpler just to write w. Okay, so we just have to compute. V dot n is going to be, okay, well, what's v? V is 3 minus 2, 2. So v dot n is 6 minus 2 minus 6. 6 and minus 6, this gives minus 2. What's n dot n? N dot n is 4. 14. Okay, so what I get is that this is equal to negative 2/14 times n. Okay, I could simplify that, I guess, 1 over negative 1/7 times 2, 1 minus 3. And I'm just going to keep this fraction outside rather than writing divide by 7 and changing all the negative signs. And now what's u? Well, u is v, which is that vector, minus w. Okay, so minus minus 1/7 will be a plus 1/7. 2, 1, minus 3. And, okay, so this right here is the green. This right here is the purple. And I'm okay if you leave them like that. Obviously, we could expand out the purple and say this is 3 plus 2/7, negative 2 plus 1/7, 2 minus 3/7. And I don't think this is really better. We could maybe even go further and say this is 21/7 plus 2/7. This is minus 14/7. Again, this is plus 14/7. Minus 3 is 11/7. So yeah, like this is maybe simplified, but this formula is enough. And let's just label it, because we're asked to find the normal and tangential, so I have to demonstrate I know which one is which. This is tangential. Here we have it. It's in the plane. That'll be sort of tangent. Later our plane will be tangent to some crazy curved surface, and then the vector is tangent to the surface. And then this green one is normal to the plane. Okay, that's it.